In the history of car manufacturing, Tesla is the only company bold enough to bring a machine the size of a four-story building into a factory. China has tried multiple times to replicate Tesla's production line, especially the Giga Press machine to speed up EV manufacturing. But it seems the 9,000-ton Giga Press is the biggest they've been able to copy so far. Now Tesla has taken things to a whole new level by deploying a 50,000-ton Giga Press to produce 5 next-gen vehicles in a single casting, with each mold taking just a few seconds at incredibly high output. That means every minute, nearly 5 Teslas roll off the line, just like Elon Musk emphasized.
I think it'll be able to produce a car ultimately in less than 5 seconds. Like, can you imagine a car coming off the line in less than 5 seconds? That's like, whoa.
Sounds like an exaggeration, right? Even the cheapest cars usually take close to a minute just to roll off the line. 5 seconds? That's like a car shooting out of the machine like a bullet from a gun. You might not believe it, and honestly, neither did we at first. But this machine is real, and it's going to put massive pressure on Chinese automakers. Why? Let's break it down right now. You might not know this, but the Tesla Giga Press is a rather strange machine. Despite its massive size and weight, thousands of tons, and a wide array of different systems, what happens inside this machine truly left us speechless. The operation of the 50,000-ton Giga Press could easily be considered an engineering marvel in 21st-century automotive manufacturing. At its core, the Giga Press is a high-pressure die-casting machine, and this isn't a new manufacturing process invented by Tesla. Casting has long been a crucial part of the automotive industry throughout its history. It's been used to create vital components like engine blocks, transmission cases, and front or rear frame sections for electric vehicles. However, what's unprecedented is a single casting machine being able to cast both the front and rear frames of an entire vehicle's underbody in one go. That's something the industry has never seen before. The highest clamping force ever achieved by a die-casting machine is 50,000 tons, and Tesla will be the only company to take advantage of this machine to produce its highly promising next-generation vehicles. According to Elon Musk, these vehicles will be sold at affordable prices, which means demand will be massive. Tesla needs a machine that can manufacture fast enough before they're faced with millions of orders. Tesla has already used a 6,000-ton casting machine to produce the rear frame of the Model Y, and a 9,000-ton machine to cast the frame of the Cybertruck. Both machines have proven effective in reducing costs, speeding up production time, and delivering highly efficient underbody for the Model Y and Cybertruck. So it's no surprise that Elon Musk wants to scale this efficiency across all of Tesla's new models using an even larger system. While a traditional die-casting machine typically has just one mold, the 50,000-ton press will have at least 5 molds, allowing it to cast 5 underbodies in a single cycle.
In a single casting machine, we could do like 5 at a time or something. I'm trying to think, like, how do you scale castings? Because you got liquid metal's got to cool, and then you've got to automate, getting all the bits and pieces off the casting so it's usable.
The molding process of the 50,000-ton press used by Tesla is also more advanced than that of standard casting machines. We'd even say it's more complex. Understandably, with more molds, the aluminum metal has to travel farther, which increases the chances of defects. If the injection is too fast, air bubbles can form in the metal, compromising the structural integrity. But if it's too slow, the metal may start to cool before fully filling the mold, resulting in incomplete or uneven parts. That's why the casting system of the 50,000-ton Giga Press must operate with extreme precision, down to the exact second, the exact millimeter, or even more. First, a new aluminum alloy, along with leftover aluminum from previous castings, is heated to 850 degrees Celsius in a melting furnace. The solid aluminum blocks quickly melt down into liquid aluminum in this furnace. The molten aluminum is then transferred to a holding furnace, where the temperature is kept stable between 750 degrees Celsius and 850 degrees Celsius. To ensure quality, the furnace chamber is filled with nitrogen gas to prevent oxidation, while argon gas and a silicon carbide filter are used to remove impurities. Before each casting cycle, a thin layer of soybean oil is sprayed onto the mold to make it easier to release the vehicle frame once it's complete. A vacuum system removes air from the mold, and then the molten aluminum is injected into the mold cavity at extremely high speed by a high-speed piston. This process requires absolute precision. If the aluminum is injected too fast, Air bubbles can form and ruin the part. If too slow, the metal may cool before the mold is fully filled. Once the molten aluminum is injected, the mold is rapidly cooled, and the vehicle frame is extracted at around 400 degrees Celsius. It's then placed into a cooling tank to bring the temperature down to about 50 degrees Celsius. Finally, a robot cleans the mold and prepares it for the next cycle. This is a basic and easy-to-understand overview of how the 50,000-ton Giga Press works. While everything in reality is far more detailed and complex than what we've just described, this is the simplest way to visualize the operating mechanism of this massive machine. As we mentioned earlier, Tesla won't be using the 50,000-ton Giga casting technology for the Model Y, Cybertruck, or Model 3. Instead, it will be used to manufacture two next-generation vehicles, the Cybercab and Model 2. These cars are significantly smaller than the current models, and the goal of this massive machine is to cast the entire underbody of the vehicle in a single shot, including both the front and rear frames. This not only saves time but also eliminates dimensional errors and makes the assembly process much easier. Okay, if the 6,000-ton Giga Press was already an engineering feat, then the 50,000-ton Giga Press represents a groundbreaking leap forward. With the ability to generate 8.3 times the pressure of the 6,000-ton version and 5.5 times that of the 9,000-ton version. Casting 5 Model 2 and Cybercab underbodies in a single shot is completely achievable. The Model 2 and Cybercab will share about 70% of their design and dimensions, featuring a compact form with short front and rear overhangs. Compared to the Model Y, which has over 200 structural components, these two vehicles will use only around 80 parts, a reduction of more than 60%. This dramatically simplifies the assembly process and significantly lowers production costs. According to Elon Musk, the production line using the 50,000-ton Giga Press operates so fast that humans can't even get close. The entire process, from melting the aluminum to high-pressure casting, mold cooling, and frame removal, is fully automated.
The design of the Cybercab line, it doesn't look like a normal car manufacturing line. It looks like a really high-speed consumer electronics line. In fact, the line will move so fast that actually people can't even get close to it.
For the entire underbody of these two vehicles, there's no method that can effectively replace casting. A typical vehicle frame is usually made up of many stamped parts. Stamping is much simpler than casting. You just take a flat sheet of metal and press it into shape, using a tool with the desired form. Then you have to join dozens of these stamped parts together by welding, riveting, or even bonding them to create a complete frame. This process is quite complex and labor-intensive. The Giga Press has revolutionized this process by eliminating all the complex steps and replacing them with one massive machine that performs a single powerful action to produce the final product. Not only is it faster, but it also delivers greater consistency and superior quality. Most importantly, every time you join separate parts together, you create connection points that are prone to cracking or failure. The Giga Press eliminates those weak spots, resulting in a much stronger and more reliable frame for the Model 2 and Cybercab.
So I mean, we got to jam the liquid metal in, cool it down real fast.
Compared to earlier versions, the 50,000-ton Giga Press is equipped with an ultra-fast cooling system, an intelligent mold release mechanism, and a cutting-edge AI-powered quality inspection system. This system analyzes X-ray images and real-time data from temperature and pressure sensors to detect defects with high accuracy, without any human intervention. It's a breakthrough compared to the 6,000-ton and 9,000-ton Giga Presses, which were advanced in their own right, but didn't reach this level of deep automation. Although the 50,000-ton Giga Press is massive and even requires a specially built facility for installation, it makes up for it by eliminating the need for many other robots on the production line. A single 50,000-ton Giga Press could allow Tesla to remove over 1,000 redundant robots. Currently, Tesla's Gigafactory Shanghai produces one Model Y every 33 seconds, according to Lars Moravy, Tesla's VP of Vehicle Engineering. What does this mean? With a minimalist design and an optimized production line, the Model 2 and Cybercab could reach unprecedented production speeds. If Tesla deploys two production lines, each producing a frame every 5 seconds, The company could manufacture up to 178,000 vehicles per week, equivalent to more than 7 million cars per year. You might not know this, but the journey of the Giga Press to Tesla is quite a dramatic story. It all started with what seemed like a simple problem, but was actually a major bottleneck in car manufacturing. Welding car frames was taking too much time and labor. One day, Elon Musk looked at Hot Wheels toy cars, which are made from a single die-cast piece, and asked himself, why can't we do the same with real cars? That question sparked the idea that led to the creation of the Giga Press, a massive die-casting machine capable of producing an entire vehicle frame in a single shot. However, turning that idea into reality wasn't easy. Tesla approached 5 of the world's top die-casting machine manufacturers, but all of them rejected the concept, believing Musk's idea was impossible. It wasn't until Tesla reached out to Idra Group, an Italy-based company under the LK Technology Group, that they finally got a hopeful response. It's possible. From there, Tesla and Idra worked tirelessly for over a year to develop the Giga Press. The result was the first 6,000-ton Giga Press, which was put into operation at Tesla's Fremont factory in late 2020 to produce the underbody of the Model Y. It's fascinating to see how Tesla tackled the challenges of large, single-piece die casting, and this machine has proven to be a game-changer. While competitors like General Motors, Hyundai, Volvo, Zeekr, and XPeng are also investing in die-casting technology, only Tesla has dared to push the limits with a 50,000-ton machine. There's been a challenge that has puzzled automotive engineers for over a century. How do you build a high-quality, consistent car while doing it as quickly and as cheaply as possible? In the 20th century, Henry Ford changed the world with his solution, the assembly line. Now, in the 21st century, we have the Giga Press. Clearly, the 50,000-ton Giga Press is more than just a machine. It's a symbol of Tesla's relentless innovation and ambition to lead. By turning an idea inspired by toy cars into reality, Tesla isn't just building the Model 2 and Cybercab, affordable EVs for the masses, it's redefining how the world manufactures automobiles. With unprecedented speed, precision, and automation, the 50,000-ton Giga Press is proof that Tesla isn't just competing, it's shaping the future. Chinese automakers have a long history of learning from and adapting the technologies of global competitors. In the past, they were often criticized for copying designs and technologies from Western and Japanese brands. But over the past decade, they've made major investments in R&D to build their own innovation capabilities. The Giga Press has now become an attractive target for Chinese automakers after seeing the benefits Tesla has achieved with the machine. However, one of the biggest challenges Chinese automakers face is replicating the special aluminum alloy Tesla uses. Developed with support from SpaceX's materials engineering team, this alloy isn't just strong, it also flows smoothly during casting, resists corrosion, and offers high ductility, eliminating the need for heat treatment after casting. Reproducing this alloy requires advanced materials engineering expertise, something Chinese companies are striving to achieve through investments in R&D and partnerships with research institutes. BYD is looking to develop proprietary alloys tailored for its own electric vehicle applications, with a strong ambition to surpass Tesla in the long run. From our perspective, Chinese automakers truly possess distinct advantages. The massive domestic market provides the scale necessary to test and roll out new technologies efficiently. In addition, the Chinese government strongly supports the EV industry through subsidies, tax incentives, and investments in infrastructure, creating a favorable environment for companies like NIO and XPeng to access the capital needed to develop cutting-edge technologies like the Giga Press. Some companies are also exploring alternative approaches such as using smaller casting machines combined with advanced assembly techniques to achieve similar efficiencies without directly replicating the Giga Press. However, simply copying the Giga Press may not be enough for Chinese automakers to surpass Tesla. The Giga Press is more than just a machine. It's a key component of Tesla's holistic manufacturing philosophy, which emphasizes process simplification, efficiency, and relentless innovation. While Chinese companies are growing rapidly, they are often criticized for prioritizing speed and cost over long-term quality and durability. To truly compete with Tesla, they must not only replicate Tesla's technologies, but also develop their own unique innovations. For instance, BYD has pioneered its blade battery technology, offering advantages in energy density and safety. Integrating such innovations with Giga Press-like manufacturing techniques could help Chinese companies differentiate themselves and stand out in the global EV market. The race to replicate the Giga Press also reflects a broader trend in the automotive industry: the shift towards smart, highly automated manufacturing. Chinese automakers, with their agility and access to resources, are well positioned to capitalize on this trend. However, to succeed, they must overcome technical, regulatory, and strategic challenges, while also fostering a culture of innovation similar to Tesla's. Can competitors catch up? Maybe. But for now, Tesla is already far ahead with its 50,000-ton Giga Press. Meanwhile, the Tesla Model 2 is a strategic product designed to bring electric vehicles closer to the mass market. With a price point of around $25,000, the Model 2 could help Tesla achieve its goal of making EVs mainstream, offering an affordable and eco-friendly solution for everyday consumers. With its superior performance, long driving range, and advanced tech features like autopilot, the Model 2 is expected to attract a large wave of new customers and further accelerate the global transition to electrified transportation. On the other hand, the robotaxi Cybercab represents a large-scale autonomous ride-hailing network. It's expected to deliver convenient, cost-effective transportation through fully self-driving vehicles. Operating 24/7 without a human driver, the Cybercab would significantly reduce operating costs while offering fast, safe service. Both of these products not only reinforce Tesla's leadership in the automotive industry, but also pave the way for an entirely new business model, one that meets the growing demand for low-cost EVs and autonomous transportation services. We hope we've helped you gain a clearer understanding of the Tesla Giga Press machine and the molding process. Let us know in the comments below what you think about this machine. Do you think Tesla will roll out even larger casting presses in the next decade? And don't forget to hit the like button if you enjoyed this video. It really helps our content reach more people.